Okay, good morning everybody, and thank you for attending my talk. So I will talk about BtleJuice, a little framework I wrote some months ago. And this framework allows anyone to perform man-in-the-middle on the Bluetooth Smart or Bluetooth Low Energy protocol. For those who don't know me, I'm Damien Cauquil, a senior researcher at CertUbic, which is the cert of digital security company. I'm at the head of research and development, and I focus on Bluetooth Smart since 2014. Sorry, I had to run a bit. Sorry. So, what are we talking about in this talk? First, I will recall some basics about Bluetooth Smart and Bluetooth Low Energy. That's the same. And then I will talk about the sniffing process when you want to intercept or study some Bluetooth communications, and especially this Bluetooth Smart communication. You have to intercept these communications. And one way to do this is to use some sniffers, but it does not work well, and I'm going to explain why. Then we will switch on the man-in-the-middle attack on Bluetooth Smart. So I will explain all the process, all the tools, and the framework I developed. And hopefully, if I am very lucky today, I will be able to perform some live demos on some stuff I have, such as a tiny robot, a blood glucose meter system, and some, I don't know what, it's basically called a smart padlock. So this is some kind of access control device. So, Bluetooth Smart or Bluetooth Low Energy, what is it? So this, first of all, this is a very, very popular protocol used in all the IoT stuff and connected devices. So you may find this protocol used in medical devices, such as monitoring devices, thermometers, heart rate monitors, and so on. But also in access control systems, such as smart locks, padlocks, door locks, and of course sex toys. You know, the sex toy industry jumped very, very fast on this protocol, and there are many, many sex toys that are connected with this protocol. I'm not going to make some demos on sex toys, of course, but could have been fun. So this Bluetooth Smart protocol is part of the Bluetooth 4 specifications and for the versions of this protocol, and it was designed for low power devices. And it's also known as Bluetooth Low Energy, so this is why. It's lighter than the Bluetooth Classic. Bluetooth Classic is the old version of Bluetooth, if I could say. And it is widely used in tiny embedded devices. First, it operates in the 2.4 gigahertz bandwidth, same as Wi-Fi and the classic Bluetooth. And it uses 40 channels of 2 megahertz bandwidth each. So it's basically, it uses basically the same frequencies as the Wi-Fi protocol, but with some specificities. And one of them is that this protocol uses 3 advertising channels. That means, I will talk about it later, but it's one of the main reasons why sniffing sucks. And also, it uses frequency hopping, split spectrum. I mean, when you are using this protocol, it doesn't use only one frequency to transmit information. It jumps from one frequency to another with a specific pattern based on some characteristics. The protocol stack is the following. You have the physical layer, link layer, a very specific protocol called L2CAPE, which is also implemented in Bluetooth Classic protocol. And the upper layers are very specific to Bluetooth Smart, that is the GATT and AT protocol, and the profile identification layers. I will detail very quickly all of these layers. They are going to be, if you want to get more information about this layer, the white paper I wrote and that will be released right after the conference contains a lot more information about it. So the link layer provides 2 roles, a master role and a slave role. Masters manage multiple connections with slaves. I mean, your smartphone is in master role when it connects to a device. And the slaves usually manage a single connection at a time with the master. That means you can only have one master connected to a slave or a device at a time. And this is very interesting because we can abuse this to create a man-in-the-middle attack. The link layer the link layer control all the packet transmission, and it provides all the features required to transmit packet and transfer packets. But it lacks retransmission and flow control, which are normally implemented for Bluetooth Classic protocol, and this for efficiency. The gap, that means the generic attribute profile, defines 4 roles including central and peripheral. This is a specific terminology, but central basically are run in master role, and the peripheral role defined by the gap is used mainly on devices. Based on this is the attribute protocol that provides the main features of Bluetooth Smart. That means it provides services and characteristics. A service provides many characteristics, and your device may implement some services and basic services. Services and characteristics are referenced by UID, which can be of 60 bit long or 128 bit long. It depends on the specifications. And there also are some standard services and characteristics defined by the Bluetooth SIG. I mean, if you want to create a device that will be used to monitor your blood pressure or your temperature, every thermometers or blood pressure systems will use the same profile and must implement the same services and characteristics for interoperability. So if you have an application that want to use some kind of Bluetooth-enabled, I don't know, thermometer, all the thermometers would implement these services and characteristics. So this is one of the key feature of the attribute profile and the gap profile, the generic attribute profile. Sorry, and this is a very interesting way. We'll see later why. And for the characteristics, we can perform some operations such as read, write, and also notifications. So notifications are designed for low power devices. I mean, if you want to be notified when the device wants to send you information, you use this system. You are using this notification. You register for a notification, and once the device modifies or writes some information in the characteristic, you get notified, and you get the information right at the right time, just after the device modified it. There is also security integrated in this protocol. So this is provided by the Security Manager protocol. It provides authentication, authorizations, integrity, and confidentiality with encryption. So the Bluetooth Smart protocol is designed to be secure. Well, it's thought to be secure, but not very well used at this time. Just to go a bit further in the security features, to enable encryption on a Bluetooth Smart connection, you have to pair a device with another one. So you have to perform some pairing. And how this pairing is performed, it's very, very simple. First, both devices exchange their capabilities. So if I have a smartphone with a screen and a keyboard, and say a secure hard drive, well, shouldn't be used with a Bluetooth Smart, but anyway, a secure hard drive with a screen and a keyboard, both devices are going to send to the other their capabilities. I have a screen, I have a keyboard, and so on. Why? Because based on this, they will agree on the method to use to exchange a key. If you have a screen on the device and a keyboard on your smartphone, the device may display a PIN code that the user will enter on the smartphone. So it's a way to avoid man-in-the-middle and to enable encryption. So if the devices are able to exchange a PIN code, then a key is derived first from the PIN code. So this is here the short-term key, which will be used for a very short amount of time. But if the devices have no keyboard or screen. There is a default mode, which is very interesting because it's called the Just Works mode, the Just Works pairing. And basically, the pin code is the default one. So basically 4 zeros. So of course, the keys derived from this are not so default, but this is a weakness of this pairing system. But if it's well performed and well used, then the long-term key exchange at the end is very secured. And the key process here is that this pairing must be done in a secure area. So once it's done, the key are exchanged, and then both devices may communicate securely. So for you pair once, and then every time you create another communication or connection through Bluetooth Smart, it will be secured, encrypted with these keys. So if someone tries to intercept the communication or sniff the communication, everything is encrypted, and you cannot break the key until you are sniffing this pairing process. When you want to create a connection, a Bluetooth Smart connection, you have to perform some steps. First, you have to know that the peripheral sends advertising packets. What are these packets? It's basically some packets telling what the device is, what's his name, and what are its capabilities. And it's sent over one of the 3 advertising channels. So generally, every device sends on the 3 channels in a specific order. But at a given time, it sends just an advertising packet on a channel. Then the central, listening on the advertising channel, got the advertising packet and sent a connection request. So this is a specific packet asking for the creation of a connection. And when the connection request is received, the device starts initiate the connection, and they start jumping from one channel to another, one frequency to another. So it becomes very difficult to follow this communication if you don't have the parameters used to jump from one channel to another. So this is one of the key problems when you try to sniff this system. So why sniffing sucks? First of all, you have to use dedicated devices. Here are 2 of them, the Adafruit Bluetooth LA sniffer and Bluetooth one. Maybe some of you have already played with this kind of tools. So these are basically sniffers for the Bluetooth one based on some SDR stuff, and the Bluetooth LA sniffer is based on the firmware written by Nordic Semiconductor, which is the manufacturer of the chipset. So these sniffers work, but it's very, very inaccurate, because if you already used this, you may have experienced a lot of problems with them. Because if you want to sniff correctly a connection, a Bluetooth Smart connection, you have to intercept at the right time the advertisement packet and the connection request packet. And since we have 3 advertising channels, you have to be lucky to sniff at the right time on the right channel to get this packet. I mean, you have one chance out of 3 to get this connection initiation and to get the connection request packet. And you can only sniff the connection if you got this packet. So this is one of the problems we may face. So you have to be lucky. And another problem is the sniffer itself. Why? Because the sniffer for Bluetooth, for instance, it's based on SDR. So if you have a lot of noise in the around this frequency, you will get this noise, and your sniffer may try to disassemble or analyze what looks like a Bluetooth Smart packet, but in fact that's not a Bluetooth Smart packet. So it wastes time decoding some noise, and you may miss the right packet because of this. And a lot of security researchers faced this problem. And here, Sami Kamkar trying to perform some kind of sniffing on Bluetooth Smart protocol. So he used some kind of an aluminum basket from IKEA with some tricks just to be sure to intercept the correct communications. And it doesn't work well because the sniffer is inaccurate, as I said. So I spent some months thinking about a new way to intercept communication, Bluetooth Smart communications, and to get valuable data from this. I mean, I wanted to have a tool, a very efficient tool, able to intercept these communications. So the approach I designed is a very common approach based on man-in-the-middle attacks. And the fact is, it's easier to create a new device with exactly the same characteristics, not the Bluetooth Smart characteristics, but the same global characteristics, and force someone to connect to this fake device. So the idea is to create some kind of proxy with a dummy device that your smartphone will connect to, and then forward all the operations, the GET operations, to the real device. And remember what I told you at the start of this talk. Many devices only manage one connection at a time. So all you have to do is just to create a connection between your proxy and the real device. And when this connection is made, both proxy and device will start jumping from one channel to another. So it will not advertise itself no more. So it's very easy then to create a new device with exactly the same characteristics and advertise it on the 3 advertising channels. So this way, we force the smartphone to connect to our dummy device, and that's it. It's very efficient, it works, and it's more reliable than the sniffing system. Pairing is not very a problem no more because we can undo the pairing between the proxy and the smartphone. And you don't need some specific hardware or expensive hardware because it works with a standard BT4 USB adapters. Even the ones that are already installed in your system, on your motherboard. So for this, we need a dedicated proxy to perform this man-in-the-middle attack. So the proxy connects to the target device. I create a profile. So it looks, it listens for every services, every characteristics, get all of this, because this is announced based on the Bluetooth Smart protocol. And then it creates a dummy device that looks exactly the same with every services and characteristics, and just waits for connection on this dummy device, and then relays everything, every operation to the real one. So the working of this man-in-the-middle tool or man-in-the-middle framework is very similar to well-known HTTPS proxies. For instance, if you're very familiar to Burp or Zap, this is exactly the same, but for Bluetooth Smart. The architecture of this framework is very simple. We have a proxy, which is a piece of code providing all the stuff to connect to a real device, and then a core system that proxifies everything and creates the dummy device. And on top of this, I built a web UI, a web user interface that you may use to see what happens, and also some bindings in the Node.js and Python in order to interact with some kind of command line interface. So if you want to automate some attacks, it's possible with this. So with this framework, we can perform some live GET operations and data sniffing. This is a burp-like interception, as I said, like OWASP or ZAP or burp. And it also provides a web user interface and some export features. But there are some drawbacks using this technique. You have to use 2 machines because the Linux stack, the Linux implementation of the Bluetooth devices does not allow for the Bluetooth 4 specifications 2 stacks for two adapters. It's the same stack for both of your adapters, so if you have both of them, or 3 of them, or 4 of them, I don't know. But there is a single stack, and this will mess with this attack. That means you cannot create a dummy device and connect to a real device at the same time. So this is why we use 2 machines to solve this problem. And you need at least 1 USB Bluetooth 4.0 compatible adapter, ideally some kind of Cambridge Silicon radio. Why this one? Because it allows MAC spoofing or Bluetooth address spoofing. So it may be useful to test for further testing. And Node.js, which is the base system used for this proxy and system. So it's very easy to install. And you have some command lines here. Just, you install all the dependencies, and then with npm, with the Node package manager, we install the BtleJuice, and you have a nice interface. So I will start the demo now, trying to show you how it can be performed and what the interface looks like. So I've installed, well, 2 minutes. So here it is. So I've installed all the software and started almost all the stuff. So, live demos. Okay. So here it is. Here is my web interface. So I'm connected. With this interface, I may list all the devices. I don't know if you, whoa, many of them here. Well, doesn't matter. I will just show you what can be done with this smart block, for instance. So I'm just pushing some button. So the blue light here indicates that there is an active connection on this padlock. And if I use a specific client, just to show you here, so this one is my smartphone. I'm going to connect to this. So this is this one. Okay. Connect. And here my smartphone is connected to the dummy device, and everything done with this is everything done on this dummy device is forwarded to the original device. So I can get the device name, for instance. There is the attribute. So here you can see. No, not this one. Yeah. Here the device name is not correctly spoofed, but anyway, this is a VirtualBox, which is my machine here, and I can read the battery level of this one. Battery service, battery level. Not connecting no more. This one disconnects very quickly. So here it is. We are just reconnecting, and if I am fast enough, I will show you the battery service. So this is the battery service and the battery level. So this one is 68%. Again, sorry. So here, the battery level is 68%, so it's pretty cool. So with this interface, it's very easy to perform some kind of stuff, and of course with the bindings we can do many more fun stuff, such as messing with the battery level. If I want to perform some kind of modifications, on-the-fly modifications, I can use this attack. So this is basically some Python script performing the on-the-fly modification. The code is a bit awkward, but the working of this attack is very simple. It provides 100% battery level, and then it decreases each time the characteristic is read. So I'm going to use it. So this is this one. Okay. Okay, proxy is ready, so it's fully automated. I'm just going to shut down this one. I don't want this one to mess with my stuff. All right. And that's it. So if I connect again on this, like if I connect back to the smart lock, smart padlock. So here I'm connected, and I'm going to read the battery level. Did it work? No, it's not connected. Not ready to work again. Come on. I'm going to start again. Okay, so proxy is ready. I'm connected. This is the problem with demos. I don't know how many time left. Okay, so battery level here is 99%. So I don't know if it's very, very easy to read, but if I read it again, 98, 97, 96, and so on. So my code is messing up with all the read operations and spoof the result of this on the fly. So it's very interesting to maybe try some fuzzing or so on. There are many attacks that can be done with this kind of stuff. So there are some limitations with this on-the-fly modification. I mean, since it goes from Bluetooth Smart to some kind of WebSockets used by my system, and then Bluetooth Smart again, it takes some time to perform some operations. So there is an induced latency by design, and of course there is some limitations based on the libraries I'm using on this software, which limits the number of bytes you can write on the web operation. So just to perform some much more interesting demos. So here I've shown the padlock, but I'm going to use it with the right application now, just to show you that we can do much more interesting things with this. So I'm going to get back to the web interface. I'm going to connect to my padlock. That's it. And launch the application used by this padlock. So this padlock is already registered. I can unlock it if I want. As you can see, it's open. But the fun stuff is that if you look here at the data sent by this padlock, it's very written in very little policy. So here, you can see 1, 2, 3, 4, 5, 6, 7, 8. This is not some kind of random data. If you look at my configuration with my padlock, this is exactly the pin code I set for this padlock. So it's sent in clear text without any authentication or encryption. So if you want to buy one of these, maybe you shouldn't. So pin code is sent in clear text, and this is very easy. If you want to perform this attack in real life, all you have to do is just to create this kind of proxy and wait for someone to open the padlock. When the padlock is open, you get the pin code. And the fact is that this pin code and my smartphone are not really paired. I can use this padlock with any other smartphone without any problem. So take your smartphone, install the application, enter the pin code when it is required by the application, and you will be able to open or close this padlock as you wish. So it's pretty interesting. The second demo is a bit tricky. So this is based on this robot. So this is a Chinese robot. Normally it's designed to stay up. Yeah, that goes, I mean, it's not very... Wait. Let's try again. Come on. Don't move. Yeah. This one, as I said, is... this is the problem with live demos. You have to go very fast. So I'm creating the proxy for this device. So my system just configuring the proxy normally. have to be lucky just to see if... oh, so this one's trying to mess with this. Come on. Just restarting everything just to be sure. There it is. So, back to this one. Here it is. Okay, proxy is created. Hope so. And we start the application to drive with this. Try to connect. So it takes some time to connect to the dummy device. Hope this works. Nope, it was not mine, my proxy. Sorry. This one. Just give me 2 minutes. So, well, I'm going to show you this in video. It will be easier. Sorry? Oh, it takes 1 minute, 2 minutes max, and I will stop after this for the demos, just to jump to the conclusion. So this is a video with this robot. So I'm creating the proxy just to show you the system. So no, this is the quick lock one. So sorry. Which one is the good one? Nope. Okay, so this video was not open anymore. This is this one. Okay, so I'm creating other proxy stuff and so on, just as I did right here. So once the proxy is created, I'm using the application to communicate with the robot. Well, the fun stuff is about what we are going to hear. So when I modify this value with the value 1 in this particular write operation, it makes the robot beeps. But if you modify it to 2, so this is obviously not is not used by the normal firmware, but it was introduced in the firmware by the developers. So this is a hidden feature, of course. So by using my framework, it's very easy to test some values of first with the characteristics. So anyway. So for this robot, there is absolutely no encryption, no repeater protection, and it is not authenticated. I did the same with the blood glucose meter system. And by making a proxy, I was able to inject some fake values in this system. This is a great problem for this device, because it's used to transmit data to some kind of remote services used for e-health. So it's let's see the right video for this one, just very quickly. So this is my glucose my system, so I'm going to set the proxy exactly the same. And I scripted the attack, so this one will create a dummy device that looks exactly the same as the blood glucose meter system, but it will send random values each 5 or 6 seconds. So each time the system reconnects, we send it a wrong value. And this value, if the device is paired with some kind of remote services, then these values are sent to a doctor that will review all of this and maybe change the quantity of insulin that will be delivered to this patient. So this may be a health problem, and some patients may be injured by this kind of attack. Well, anyway. So again, no encryption. The authentication is only based on the Bluetooth device address that can be spoofed by some kind of Cambridge Silicon radio adapter. So attacks are very possible. The countermeasures for this man-in-the-middle attack. So if you keep your BD connections alive during a very small amount of time, then the man-in-the-middle system would be able to create a dummy device, but you have more chance to make the smartphone connect to your original device than the dummy one, because there is some kind of time required to create the dummy device. So maybe used. So there is also timing detection due to the latency induced by the system. And if out of band or pin code pairing is required, then there is some kind of user interaction, and you cannot perform this kind of attacks in the real world. And of course, you can use application-level encryption to avoid this kind of problem. So if imagine this padlock sends AES encrypted data with a pre-shared key, I won't be able to get this pin code. So just as a conclusion, BtleJuice can be used as a security analysis tool if you want to analyze how some device, how a device works, what are the data exchange between your smartphone and the device or between two devices. Then you may use this framework, you must use this framework, and it works pretty well, and able to bypass MAC filtering or some, and so on. And if you want to use it as an attack tool, remember that you need two machines, and it's quite a complex setup, and it's not very portable or embeddable. If you want to create a very little teeny machine that implements all of this, it's not so easy. And for the future work, so I'm going to try to solve the two-machine problem and solve some of the long write problem due to the library this tool is based on. And of course, we need more and more testing. So if you guys want to try this tool, give it a try and make some analysis and report issues on the GitHub of this project, will be very nice for us in order to improve this tool. So just a few words. Sorry. There is another tool presented at Black Hat this year. I wasn't aware of. This is GreHack by Slavomir Jacek. And this is a very similar tool without all the user interface and so on. So it may sometimes be better because it uses another approach for the man-in-the-middle. So if you want, read the white paper of this guy and you give it a try at this GreHack tool, just to make your mind.
So obviously there won't be any questions.
Thank you very much.